Okay. Well, I apologize for the absolute disaster. Yeah, I apologize for the absolute disaster just happened. Router accidentally disconnected. Anyways, we didn't miss anything giant. But basically, let's see. So we didn't miss anything giant, don't worry. But it did suck. But that's just my internet randomly at no apparent reason. And now YouTube's saying it's 7:58 p.m. for me, which is not correct. Protected mode segment. If you didn't know what happened in that small time, I was able to figure out what was exactly going on. I mean, sure, it was interesting. Now, let's take a little look-see. So, again, undefined 8 immediately straight to the long double. You guys gotta know, the long double is one of my favorite of a kind. Because, as I say, long double, no trouble. I know it's cringy, but honestly, I think my saying's pretty interesting. Myself, anyways. Anyways, that's all undefined gone. Now we just have to figure out some variable names. Then this code will be complete, apart from this stupid thing. Now, let's figure out what this does. It's an unsigned int, meaning it's basically positive only. Let's do some reference finding. Okay, so set the 1 down here, then set the 3. And it's used as right module specific register, along with the address. So this is an unsigned, it turns it into an unsigned long. So it's basically, let's do a little Googling here. Let's do, so it's a Windows driver thing. Okay. Now, let's see. So since it's writing a specific, it was write to a module specific register. Oh yeah, that's what it was. That's the good stuff right there. Oh god. So it's giving us not much information apart from it only being assigned 2 times, and then it's first off it's being defined once, assigned twice, and used once. So let's read what this. So if the data address, or oh wait, sorry, up here. If pointer variable does not equal 0. Interesting. Undefined is 0. Okay, apparently there's more to do because there's some undefined looking here. So, if we use a little brain cell thunk, then probably figure out. Okay, so we have some function. Ooh, there's more down here. How did I not see this? More variables. Let's just worry about this one for now. It's so basically it's saying if pointer unsigned variable 2 is not equal 0, and it'll go into this. Now it's saying if this data address plus another value incrementing the data address by 136, and after it converts it to a long plus 36, so I'm guessing it gets the data address and then it converts that value to decimal and then adds it, which means it would have to be -36 would equal then 0. Okay. That's interesting. So then, if we were to look, it would set this UVAR. So it's writing to a register. That's what it does no matter what. If it gets in this function, it writes to a register. So if it writes to this register, okay, I'm using a brain cell func. Let's rename this variable to write to a specific register. Must be data. So, brilliant name, register data. I know, completely unseen ever before. This is probably the register it writes to, which for me would be an Intel 64-bit register. So basically, it's doing things here pretty much to check what type of register you have. Or what type of system. So, actually, it would do that at install, but right now it's probably still checking if it's running on what version and what, because you could be running on Intel 64-bit or Intel 32-bit, and those have roughly the same instruction sets, but not the same. One's x86 assembly for Intel and one is 64. See, I only know a bit of gas assembly, x86 assembly. 64-bit assembly is like a whole new thing, Okay, let's take a look at some other things up here. We got register data. Now let's take a look at this. Let's find where it's used. It is used down there and down there. So this is our pretty much what we were looking at before. Is it used anywhere else? Ooh, it's used down here. So it's only used in those areas. Basically, we got a binary shift pointer onto 32, which should most likely turn it into a whole different value. Okay. Let's think. We could probably rename this to if shift. So I have an if shift here. Let's push on to stack. Right, what else? One more up here anyway, so let's do it. Let's find where it's used. It's used down here. Down there. So it's basically just, it's just pretty much being set So we can call this the stack return data. Okay, we have the stack return data. And with the stack return data, we can now start figuring out what other stuff. So we have register data, if shift. We have our LL value, interrupt table register, generic int pointer, and we have stack return address, binary shift pointer. We got some good pointers now. Now let's figure out this parameter now. So it is only used in these two spots. So it's basically setting the data address equal to that. And then we're incrementing it here. So I suppose this might be... Let's figure out where this goes first. Let's just do some finding on this. So it's used in the generic int pointer, the if shift, another if shift, and then a function down there. It's used in quite a few places. So this is a data address with the binary shift. Let's take a look. So it's set to the parameter, so we could probably just call this data param, or even better, entry data. And there we go. I say that's set pretty well right there. Now we're gonna have to start figuring out some other stuff. So let's scroll down until we find something that's unnamed. Okay, nothing, that's good. We have a function here. It's not that long, let's do it. Fiber data. Fiber data. So, so fiber. Really?
Don't leave that on the floor.
Okay. Fiber is basically.
Huh?
Fiber is basically a thread in a nutshell. So it's useful to know. Okay. Alright, so let's take a look. So PV, where's the V? Oh, it's a void variable. I've never seen one of those. Lock. Where lock? Oh, it looks like my cat's coming to visit. Byte. Unlock. Let's do some Googling. Not C#, but C. Hi, buddy. Good boy. So basically, it locks the thread.
Derek's already visiting you.
But yeah, basically locking the thread with a fiber. Okay, now let's look what else we got here. So this is a fiber pointer. Call it that. Hi, good boy. Hi, Derek. Oh, hi, buddy. Good boy. Yes, you are. Good Derek. Oh, who's a good boy? My cat is... Oh. Why are you licking my pencil? I'm sorry, my cat's being odd. He's licking the pencil on the ground. Aren't you, buddy? You're an odd cat. Good boy. Anyways, let's take a little look-see here. Now, this was in the RAX register. So, RAX reg. And right off the bat, we already have an undefined 8. And do you know what I say with undefined 8? Double long. Where's it? Long double. Long double. Long double for trouble. Anyways, everything else is assigned, which is good. Why are you licking the pencil, huh? You got weird things going on? We got a 0. Whoa, who's a good boy? Got a while true statement. I don't see any other functions being... Oh, never mind. Let's do a quick rabbit hole thing first. Ooh. Ooh. Regret is actually a not. It's 0.0, though that actually might be a float. Should we take a look? If we take a look at our little data sheet here, Windows Standard, by the way, it is a double. So honestly, having a long double doesn't really change anything bad. So I guess honestly it wouldn't really matter. Good dear. Okay. Now we have a X10, which is 16. Yes, of course. This is probably 20. I wonder what this is. It's gonna be like 36, 48. Why did they make it so complicated? It didn't need to be this complicated. Dear, good boy. Okay, let's take a look at this very, very interesting one. So this is... Okay, so it's a pointer, of course, so... So it seems to just be... So during lock statements... so basically, when it locks, what it's doing is basically telling the system to, like, you know, put a hold on stuff. So when these things are ran, like, say it's then sets, you know, pointer valuable to all that stuff, does all that code, and when it unlocks, all that data is forgotten. So if it, like, you know, it's signed up here, the first time it's used after it's locked, after it's set the data, you know, it should have the data afterwards, but it doesn't. You'll unlock and free that data. Or memory, technically. So we could actually just call this... we could call it... We could call it... should we call it? I need some naming ideas. Someone give me a naming idea. I'm in need of a naming idea. So... Someone? Anyone? Anyone got a naming idea? Naming scheme? Really? No one? Aw, that sucks. Okay. No rush for anyone. Let's figure this out. We want variables. And we want good variable names. Alright, so let's do a little think. Big brain think here. We need to use the big brain think power. So, it did not like that. Like, you just did not like that. Let me check something real quick. Okay. So, I guess we could name it to... Fiber data holder data pointer. Beautiful name. It's one of them. Since this function, of course, is a void, I could honestly just remove void out of there. Or not. That's fine too, YouTube. Just do that also.